Hey guys, welcome to Bar Z. My name's Stan, and today we're with John at PTC Instruments, and he's given us a shop tour. And there's some questions that came in on the Facebook channel. There's some questions that I had, and we're going to find out a little bit more about this company. John, thanks for meeting me and giving
My
me the
pleasure.
grand tour. Um, First of all, what type of gauges and meters do you manufacture here?
Our primary products are surface temperature, bimetal surface temperature thermometers, and hardness testers for rubber and plastic. Then that's supplemented. We do make a couple of metal testers for hardness. We make some unusual other instruments. We make a Polariscope. We make a melting point meter, some sort of niche items. And we're also involved in making training handcuffs for law enforcement. We have a patent on it.
Oh, no kidding. Okay. How long has PTC been making instruments?
PTC is actually over 65 years old.
Oh.
This is its second location, and I've a relative newcomer here. I've only been here about 25 years.
That doesn't sound like a newcomer to me. What does PTC stand for?
PTC stands for Pacific Transducer Corp. Originally, PTC made transducers in the form of hand-wound microphone sensors or elements, and as well as hand-wound phonograph cartridges. As time progressed, we moved more into the instrumentation world and got away from actual transducer manufacturing.
Oh, okay. Now this came in on the Facebook page, and James Green actually asked, what grades are available? Is it the same as like gauge blocks and things like that? Would we have shop grade, inspection grade, and laboratory grade?
Well, we have a couple of different lines of products. Primarily, the products are classified by their published specifications. Typically, surface thermometers might be plus or minus 1% of full scale. The hardness tester here behind me is plus or minus 2 points. So each instrument has its own specification. Some of the instruments naturally are more accurate than others. And we also have a calibration lab. And here the level of calibration can run from essentially like a master level to a shop level. And the more precise calibrations are more expensive.
Okay. Well, as they should be. Okay, here's another one that came in on the Facebook page. Do you build meters or indicators that are due to be rebranded? Say, for example, if I wanted a pressure gauge that said Bar Z on it, do you offer that?
Yeah, virtually everything we make can be private labeled. Durometers, temperature gauges. Even if somebody wanted their own Polariscope labels, we're open and more than willing to work with the customers. We also make a number of custom gauges. For instance, in Durometers, we make a gauge for the Canadian Fish and Game folks to test crab shell hardness, to determine whether it's legally hard or soft, and that determines whether the fishermen can harvest them or not.
I'll be darned. Had no idea. And I did notice that you had some that were rebranded like Goodyear Tire and Rubber.
Goodyear Tire and Rubber. We have Omega. Number of, if you look to your left, there's a number of brands. Mitchell Instrument, Wall Instrument, Shalco are all companies we have private labeled for. And really, if you want a private label, you're looking at the cost of the artwork, which you might supply yourself, and then whatever the setup is for the particular dial or labels you would need.
Gotcha.
Other than that, there's no premium charge. It's just a matter of swapping the parts.
Okay. Okay. Next up, do you offer a recalibration and repair on everything you make?
Everything we make is serviceable to some extent. I mean, if you step on something or run over it with a steamroller,
Well, then
it's not feasible to repair.
I think we should replace it at that point.
But other than that, yeah, everything is serviceable and calibratable, and it's calibratable either at sort of this industrial level or in our calibration lab, and most of that can be done very accurately.
Very nice, very nice. Now, how about this? Do you recal and repair any other brands?
Sure. In the calibration lab, we can calibrate virtually any thermometer
Okay.
that's within our scope, which means temperatures typically from minus 190 C, which would be liquid nitrogen, up to a high temperature of about 1,000 C, which would be a heated electrical furnace.
Yes, it would. That's a pretty broad range to me. I don't know how far out it goes beyond that, but that seems like a pretty wide scope.
Then in pressure, we can go from a few PSI to 10,000 PSI for pressure gauges. And we also will calibrate durometers to ASTM or JIS or DIN standards of almost any manufacturer. Now, some manufacturers are no longer in business. For instance, the Shore Instrument Company has closed their doors, although we can calibrate and repair some of the instruments. In some cases, we get in trouble because spare parts are no longer available, and if it's not something we can make for the shop economically, then it wouldn't be able to be repaired. But if it's working, we should be able to calibrate it.
Calibrate it and do minor repairs, or okay, but no cases or crystals or.
Generally not.
I think you would call that hard parts.
Yeah,
right.
hard parts. But sometimes we do have a supply of indenters and specialized parts that are the most frequently needed, and often we can change that or repair, literally take it out, maybe remanufacture the part, regrind the indenter or something to bring it into spec.
If it doesn't exceed the cost of the tool.
Right.
Gotcha. Now, if anyone's interested, can they buy factory direct from you, or do they have to go through a dealer?
We have a full online store, open 24/7. If they're after better pricing, they could talk to a dealer. We always support our list price in fairness to our dealers.
Absolutely. Yeah, you'd be nowhere without your dealers. I do work through a network as well. Now, is your laboratory nationally recognized?
Yeah, our laboratory is accredited to ISO 17025 by A2LA, which is one of the major accreditation societies in the United States, and that ISO 17025 guarantees the consumer traceability to NIST. And A2LA inspectors, we have to comply with a certain number of forms and questionnaires every year, and every other year they actually come out in person, spend a couple of days, supervise tests done for them, and we also participate in national round robins where we compare our results with other laboratories. So that's been really nice in terms of our international business as well, because it puts people at ease as to the quality of the calibrations they're getting.
Okay, so there you have it. If you've got any more questions, you'd want to go to ptc1.com and look over the product line there. John's given me a big tour of this place, and we've gone over the thermometers of all different types. There's surface contact, centigrade, Fahrenheit. We've gone over the durometers. We've gone over and a lot of the pressure gauges and things like that we've looked at. One thing we haven't covered, and this will be of particular interest to a lot of folks on the channel, is the hardness tester. Now, some of you remember that I hauled a rather large service diamond hardness tester up to Ox Tools. This thing is 200 pounds if it's a pound. This thing is huge, and look what just replaced that. This thing is slim enough to fit in my toolbox, and actually while I was up there, Tom Lipton demoed one of these for me, and I'm going to give you a little peek at it here, and I'm just going to give you an explanation of how it works. If I get this wrong, please correct me. This is an optical device right here, and I use something very similar to a mag light to light the reticle, you call it. And I've got a test block right here. Next to that, I have a snap punch, a calibrated snap type punch that everyone's familiar with, but it has a very unique tip. To use this, I take the snap punch and I snap my test subject, and then through the reticle there are graduated lines of the size of that crater that I just created. And I think there's a little diagram of that crater in here that I can.
And the reticle does read out directly. There's no conversion. You can read right off the reticle what the Rockwell C hardness is.
What you're looking at there is a center punch mark for all intents and purposes. It's going to be rounded, but then you've got a 0 point on the reticle, and then you've got the hardness based on how big the crater is that you've just made. So pretty simple. It is subject to a little bit of interpretation. You're not taking a direct gauge reading, but with a calibration block in there, I think we can get some very repeatable results. Tom Lipton and I did a little test while I was up in Benicia, and we both read the same punch mark. We centered the scope on there. I took my read, passed the eyeball over to him. He took his read. We were within 1 point of each other. So even though there's a little bit of room for interpretation, 1 point of hardness is just nothing. It just falls away. It's nothing. So very impressive tool you've got there.
Thank you.
And the fact that it's compact and
robust. You know, you don't have to worry about breaking the diamond on an expensive bench tester.
I haven't dropped it yet, and I hope I don't.
No, but it's still pretty robust.
Okay. Well, I really look forward to using it.
And one hint which I passed on to you is when you do use it and you use the punch, make sure that the piece you're testing is supported well. Could be on concrete, could be on a nice heavy bench. But you want the momentum and the impact from that punch to transfer into the workpiece. You don't want to be holding it in your hand and losing that.
We don't center punch on a block of wood. You need to be sitting on something substantial to
good bench vise, a piece of steel,
anything,
concrete. Yeah. And with that, you should get nice readings. Yeah.
So if you want to look this up on the website, it's a model number 316 and made right here in the good old state of California. And like I say, I really look forward to using that. All right, John, I really appreciate you taking the time and showing me around.
Great time.
Me too, actually. This was very educational. I wish I could spend more time with you. All right, thanks again.
Thank you.
Okay, guys, thanks for tuning in. We'll catch you next time.
Make a little YouTube of our shop. So we got Jerry here doing some final finish polishing on Durometer check standards.
Showing before and after the difference, dull, polished.
Favorite 3-axis easy track Bridgeport. Takes care of a lot of the repetitive tasks for us. It's really easy to use and minimal programming skills required. We've got a couple of manual machines that do just fine. Still nice and accurate, pretty much trouble-free. We've added the digital readout to them, so we don't have much concern about the backlash. Another manual machine. This is a dedicated fixture we use for surfacing the bases of our durometers, one of our products. This is similar to the first Bridgeport. This is just a 2-axis that's automated by the Easy Track. And really great, easy machines to run. We do have a couple of punch presses tucked away in the back. We punch a few holes and stamp a few parts. For high volume, we usually send it out to a job shop, but there's always use for a manual press. And we have some miscellaneous tooling. That's a radius cutter for the hard-inch tool room lathe. Little indexing fixture. Here's a diamond sharpening wheel. Very small abrasive cutoff saw. Various drills, taps, transfer punches, silver and Deming drills. Then we're using standard manual hard-inch tool room lathe, which is no longer in production. This is a recent acquisition, a little drilling fixture that mounts right in the tailstock. Also, we retrofitted with a digital readout. Have some various milling cutters, chucks. Let's try to keep them centrally located. Here are drawer of Allen key assortments. I'm really starting to like these color-coded ones, but I forget which size is which. Got some Noga holders, some spade drilling for the big lathe. Various parallels. And I must say that after years of using Starrett, we bought a whole slew of these cheap Chinese, and we mic'd every one of them, and they're surprisingly exceptionally accurate for very little money. Sad but true. Here's the hard-inch chucker. Has a mechanically automated threading attachment, as well as the 8-position turret. This is actually how the threading attachment works. This activates it. You have a chaser and a lead screw, and you change these for various pitches. And you can program it to go through a number of cycles and how much feed, and it produces wonderful threads. Here's a small hard-inch, I guess you call it a speed lathe. We've added a tool station to it. We also have a cross slide for it. Standard old-fashioned arbor presses. Here we have some customized tooling that's used to punch slots in an aluminum can. This one's set up to shape these microscope bases. This is the beginning of the shaping process. Have the traditional small metal shear. Works wonderfully. Followed by a box pan and brake. For us, this is the workhorse lathe, 5 horsepower Morris sporting a 6-draw chuck, and for a big machine, it's surprisingly accurate and pleasant to use. Finally, we have a 13-inch Maximat, which I think probably was originally sold into the educational fields, but it's a nice lathe, and we find use for it on medium-sized jobs. Every shop should have a few drill presses. 2 of them are sporting these tapping heads, which really saves a lot of time. We have a high-speed servo drill press for smaller work with instruments. These are some thermometer cases. Work in progress. Standard part for us. Here's our quality surface plate. That's a laboratory grade Starrett plate. Try not to abuse it. Keep it covered up. lots of listed storage, end mills, taps, all sorts of various tooling, a couple of grinders. Working our way back, we added a little turret hardened, set that up. And what's interesting about these old mechanical machines is that for jobs with a number of pieces, they're every bit as fast as a CNC machine, and probably much easier to tool and to set up. This one has a bar feeder attachment, so it makes life easy. And at the end of this line, we have a precision cutoff machine made by Durometer, which we find lots of use for. Where are you in these calibration?
Yes.
So these durometers are pretty much fully assembled. You have the faceplate, the pointer, the interior mechanism, the precision spring and dial indicator movement. It has a geometry on the indenter that's specified by an ASTM specification. And from this stage, Isabel is checking them and checking the extension on a surface plate with precision gauge blocks. Around this side is the station where we can check that the correct force is applied. These are dedicated devices for calibrating the durometer. The durometer mounts on the stand. The weight is moved over, and the reading is then taken off the and it should match when calibrated to the weight. And so that is done at every 10 points. You can see on the wall the actual numbers that are being applied by the ASTM specification. From this point, once they're calibrated, they will get the cover glass, a ring, a back piece, and become a complete instrument. These are test stands that can be used to hold an instrument to remove the operator error, that it applies the same amount of force each and every test. So for companies looking for much more repetitive testing, a durometer stand is usually the way to eliminate the operator error. Moving along, these are the cases for the durometers. These are durometer stands that we have in stock ready to ship, different models. Typical of the inventory, nicely organized, tagged. Somebody very much more organized than me is responsible for this, but it sure makes it a pleasure to pick parts and to know when to reorder. Behind you, to my right, this is an electronic load cell, very precise, that can do the same test we saw on the durometer calibrator, but this is totally electronic and done by hand, and you compare the dial reading of the durometer to the actual load in grams on the readout. So it's the next step up in precision. And on this side we have just lots of inventory. These are parts for putting together the time recording thermometers. What else we got here? Here's cover glasses and bimetals. This is actually the sensing element for the time recorders. This one happens to be made for Omega Engineering. What else do we have that might be interesting? Lots of little parts, data, gaskets, whatever it takes to put a complete instrument together. Down here is a full set of calibration blocks to check the durometer. And what the calibration blocks are for is to check the extension that the dial indication on the durometer is linear every 10,000ths of an inch. It would not make a good instrument if it didn't read the correct relationship between the extension of the indenter to the dial reading. So typically the durometer might be placed between two of these blocks, and it tells you the extension and whether it needs adjustment or not. For the D-type indenter, you have to use a special device so you don't flatten the tip. The A-type durometer has a truncated cone, and so the tip is not in danger of flattening. But we actually have to hold the D scales on the edge of the cone to keep the pressure from crushing the stone, the tip. This is another instrument we make. This is a Polariscope. It has a light in the bottom. You can place a transparent part, turn the Polariscope to black out most of the field, and what you'll see in the part are a rainbow color of stress lines. No lines at all, no stress, more stress lines, so sometimes in quality control or in designing a part, this would be used. This is more assembly of these are some private labeled thermometers. These are house labeled thermometers. And we're back to our calibration. These are chart recording thermometers. The chart is rotating. The stylus is moved up and down by the bimetal sensing element. We have clock motors that can run between 24 hours and 7 days. And we have temperature ranges that go up above the burning point of paper, and we switch to a metallic, carbon-coated metallic chart. These at present are just resting at room temperature to get the initial settings. So these are paper charts. We make a chart recorder with a wind-up clock motor, and these are actually the inkless charts in various ranges that go with it. These are covered by a waxy film, and when they're run over by a scriber, it turns from white to clear, and you can see a distinctive dark line from the pressure, and hence doesn't require ink. So, various ranges. So we build a surface thermometer. We buy the dials out. We rivet the magnets in the cup that's going to contain the bimetal sensing element here. And it looks like this. From that point, we have to add the bimetal sensing element, which looks like that. And so that fits through the hub or the center bearing. And once that's mounted, the indicator, the dial needle, will be affixed. And from there, they would then look as a completed subassembly for magnets, sensing element with the indicator. From that point, they get the instrument glass, they get a ring, it's turned over, the ring is closed onto the case, and you have a complete thermometer except for calibration. We then set them at ambient, which is happening here. This is the preliminary adjustment. Then we will check them at various temperatures. We can check them on a refrigerated plate. This is right now running at about 5 degrees or 4 degrees, 5 degrees centigrade. It's cool, you can see the condensation on the plate. That's a 2-inch thick copper plate with embedded cooling tubes in it. After they're set at the low temperature, bring them over, set them at a higher temperature. This plate's, as you can see, is 57 C, sort of medium temperature. And right now our plates are running about 250 Fahrenheit, 440 Fahrenheit, and 440 Fahrenheit. The fiberglass tape on the edges prevents a lot of heat loss on the edges. These are also, these are 1.5-inch solid copper plates that give you excellent heat conduction and a nice even temperature across the plate surface. Here is a similar setup where we're calibrating pipe thermometers. These thermometers are designed to actually mount on a pipe, but the idea is the same. The pipes are either heated or cooled, monitored, and the thermometers are then adjusted to read correctly. Once all of that has taken place, we come over to the packaging station where Dory is putting the thermometers in boxes. Each box, each model has its own literature. You can see all the different literature for all the different model thermometers. So once they're packaged, they'll come around and be stored in the inventory shelves, ready for shipment. Which is here. Most of our products we have in stock for immediate shipment, and we build in order to keep the shelf reasonably full based on which product it is. The products that have more volume, we just devote more shelf space to them. And so they can be pulled from here, boxed, shipped, and out the door. Compact. This is our pressure calibration area. We're accredited to ISO 17025. This is our basic pressure generator. It's called a dead weight tester, and what it does is it applies a certain amount of weight over a certain area. So if you wanted 100 psi, you would essentially put 100 pounds on 1 square inch. That would generate 100 psi. This platform generates 2 psi all by itself. This is a 50-pound platter, so 50 plus 2 would give you a total of 52 pounds. You fill it with hydraulic fluid. Once the plate is floating, and you can control that with the hydraulics, you are now generating 52 psi. The rotation keeps the piston and cylinder from locking in a vertical motion. That slight rotation, there's a minuscule amount of oil that's on the piston wall, and it all flows. That pressure would go through this valve to this test station, and you would put your pressure gauge that you want calibrated here. Now, it could be a digital or a mechanical, whatever. If the customer needs higher accuracy, we can get approximately 50 parts per million up to 10,000 psi with this guy. It's the same principle as the first one, but each plate is individually numbered, calibrated. We know the exact weights, approximately the exact weights. There's nothing exact in calibration. We take into account our altitude, the density of the air, the temperature, the local gravity, the specific oil we're using. And if you do it all right, when you're done calculating, you should be around 50 parts per million accuracy which is really nice. The standards at NIST in Colorado are not significantly better than this. This is really the technology that generates pressure. So there's several hundred pounds of additional weights to get up to the 10,000 psi. Each platter here is serial numbered, weighed individually to, my memory serves correctly, about 100 parts per million. And so when you stack them, that uncertainty tends to cancel out. Some are a few millions heavier, a little bit lighter, and these are strictly a gloves required item.
Okay, so thank you, John, the owner of PTC, for showing me around. I spent a bunch of time over there with him. Had a really good time looking around his shop. Loved the machine shop. Loved the lab. Loved the calibration area. Had a lot of cool stuff to look at. I picked up the Model 316, which is what we were discussing over there with John. And I've got it back here at the shop, and I've had a chance to play with it. This is a great little instrument, very repeatable. And the little squares that I make, you know, according to an online recipe and the steel manufacturer's literature, I should be hitting between 59 and 60 with my tempering recipe and everything. I'm getting readings between 57 and 58 on all my squares. So I'm just a couple points below what my target was. So that's a great point of reference, and it verifies my my formula, you know, and now I can adjust to get it to where I want it. And, you know, I was kind of flying blind there for a long time, but with this, this thing has no consumables. It's just a great little workhorse, and it's so convenient for me. It's just perfect. So, thank you, John, again for showing me around. And to all the rest of the YouTubers, if you're interested in a kit like this or in anything else that they make over there at PTC, this is what he's done for the YouTube community. If you mention Bar Z or the YouTube channel, when you call in and place your order, he is offering 15% off his list prices. So he's kind of treating. He said, "Do you want to become a dealer?" And I said, "No, just let's pass the savings on to the users. You know, let's get the users a good deal on their stuff." And he said, "That's a great idea." And he said, "Well, we'll treat you as a dealer, but we'll offer the discount to the customer." Problem solved. So that's great. And he doesn't, you know, make his dealers angry that way. So you call in, mention YouTube, Bar Z, whatever. Talk to John if you can, and place your order, and you get 15% off the list prices. Okay, well, this concludes this shop tour. If there's any other manufacturers out there that would like to have their shop highlighted in the channel, and you have a shop that is machinery related or machining related, I would consider coming over and interviewing you and having a look around your shop. Shoot me an email and we'll talk about it. All right, everybody. Thanks for watching.